talking about factoring, more specifically factoring quadratic trinomials. Um, in the more common place that we use factoring, it really comes down to, um, I guess, where and when we see problems like this. To something, something like, oops, x plus 2 times x plus 3. And if we solve this problem multiplying polynomials, we know that we're using distributive property twice to solve a problem like this. We would get an answer that looks like x squared plus 5x plus 6. But let's say, for example, we didn't know what our starting problem was. How do we factor this to get, what we had originally? And that's what we're going to be doing today. So here are what we're doing. Table of contents, intro to factoring, some examples for it. Factoring part 2, which expands upon it a little bit more and shows you some shortcuts, as well as the appropriate examples for it. Yes, definitely this was a lesson that I gave to my previous high school students, and that this specific lesson does, and rather is, pretty much important to Algebra 2 as well. In your case, this is important to a few sections or a few questions in the pretest, so that's why we are also going over it as well. So factoring x squared plus bx plus c. We have learned to multiply two binomials using the FOIL method. Each of the binomials was a factor of the product. The pattern for multiplying the two binomials can be used to factor certain types of trinomials. For example, if we have x plus 3 times x plus 4, using the FOIL pattern for this, we get x squared plus 4x plus 3x plus 3 times 4. And if we're just combining them, we end up with a result that looks like x squared plus 7x plus 12. This means, and we notice that our coefficient of the middle term is going to be 7x, which is basically the sum, right, or adding 3 plus 4 together. And we notice that our last term c was 12, which is also the product, or when you multiply two numbers together, of 3 and 4. So just keeping this in mind, we can go ahead and use some sort of method to solve problems like this. For example, if we generalize this whole thing, this means that we get something like x plus m times x plus p if we're replacing 3 and 4 with m and p. And if we look at how we went about solving this, we can see that we are just adding m and p together and then also multiplying m and p together. So if we know what those two are, m and p, right, realistically, we can go ahead and convert something that looks like x squared plus bx plus c into something nicer, or its like original version before we expanded it, right? X plus m times x plus p. So some nice keywords to factor trinomials in the form x squared plus bx plus c. We want to find two integers m and p with a sum of b and a product of c. Then we want to write out our quadratic trinomial into its factored form x plus m times x plus p. So, one second. Okay, anyways, how do we solve this problem, right? In general, we just want to find factors of 20 that make it so that when we add them together, it gives us 9. So we have a nice table here, a nice organized list to help us find those pairs or factors. So for example, if we were to have, let's say, factors of 20, this is just what two numbers multiplied by each other give you 20. The first easy and nice one is just 1 times 20, and we know that if we add 1 and 20 together, we get 21. Another one that makes this is 2 and 10, right, just going down the list. 2 plus 10 gives you 12, which is still not 9, but if we get to 4 times 5, 4 plus 5 gives us 9. This means that the factors of 20, 4 and 5, will give us the factored version of x squared plus 9x plus 20. We can go ahead and rewrite this as something like this. This will give us x plus one of them. So in this case, let's start off with 4. And the last one, which should be 5. There you go. That's it. So remember, when we're looking at these kind of problems, we want to look at C, the C term, and think of factors of our C term that, when added together, give us whatever we have for B. If both of those conditions are true, then we can go ahead and use whatever the factors were for our C term, or in this case 20, and write them out into a nice pattern here, a nice format to showcase the factored version of x squared plus 9x plus 20. Let's do another example. Sometimes we can, and rather we have an interesting trinomial here, where in this case b is not positive anymore, b is negative. So we still have to think of ways in which we can showcase that, whatever the factors of 12 are, it still would create the sum of factors here for us, which in this case should be -8. But let's just think of factors of 12, right, first. So some factors of 12 include, let's say for example, 1 times 12. Another one could be 3 times 4. But keep in mind that we also need to make sure that these two factors are negative, because definitely the sum of the factors should also be negative as well. So -1 plus -12 gives us -13. -3 plus -4 gives you -7. And this means that the last one that we could probably get is -2 times -6, which when added together definitely gives us -8. So we can represent that in a nice factored version of whatever this is, x squared minus 8x plus 12. And this should give us something like x minus 2 times x minus 6. I think we have, 2 more examples, and then we'll move on to part 2. In this case, this is a little bit more interesting, wherein that in this case, our B term is going to be positive while our C term is negative. So how do we do that? Let's just read out this whole thing. When C is negative, its factors have opposite signs. To determine which factor is positive and negative, let's look at the sign of B. B in this case is positive. That means the factor with the greater absolute value has the same sign as B. In this trinomial, B is equal to 2 and C is equal to -15. Since C is negative, the factors m and p have opposite signs. So either m or p is positive. We can go ahead and choose. But we have to keep in mind that both of them cannot be negative. Since b is positive, the factor with the greater absolute value is also going to be positive as well. So let's go ahead and rather make a list of factors of -15, where one factor of each pair is negative, and also look at the pairs of factors with a sum of 2. So, -15. A few of them come to mind. The easiest one should be 1 times 15. In this case, 15 should be the positive one because our sum of factors should be positive as well. So that means our 1 should be negative. Another set of this might also be 3 times 5. 5 would be the positive number while 3 is negative. And if we add them together, we get what we want exactly, +2. The first one we get 14, which is definitely not what we're looking for. We're looking for the second one here. So creating the factored version of this, we want to just do the same thing. Write our 2 factored versions of the problems. We have x minus 3 and x plus 5, and this should be our answer. If you were to distribute all of this stuff, it will definitely equal to what we have here. Test it on your own. I'm trying to make this video a little bit shorter. Let's do another problem though, where in this case, our C term, our B term is negative, which means that the number with the greater absolute value should also be negative as well. So kind of like what we had here, but the bigger number, in this case, like 15 or 5, will be negative instead of the smaller number. So in this case, we're looking for factors of 18. I think some of us may have some problems in mind, which is fine. I mean, possible answers I'm pretty sure one of you might have said 1 times 18, which is great, but let's just go down the list. I think the next one we probably have is 3, 6, 9, 12, 15, 18. 3 times 6 is a nice one, but you're like, oh, what about 2, right? So 2 times -9 could also be it, because 2 plus -9 should give you -7, which is what we're looking for here. And then from here, we just have to write it out in its factored version or factored form. So this includes two parentheses or two grouped binomials, and then inputting the number here, right? So x plus 2, right, because we have a positive 2, and x minus 9 because 9 is negative. And that's it. We have some practice problems here. I'm going to go ahead and pause this for like 5 seconds. 1, 5, and then if you want to try these on your own, you can definitely do that on your own. Actually, maybe I'll make this into your actual assignments. I'll choose 4 of them and then also provide the answers as well. Let me go ahead and cut this video real quick, and then we'll move on to the next set of slides for this lesson.